Hello. I thought I'd talk today about life on other planets, or at least elsewhere in the universe. In particular, how can we figure it out, because we don't know. And I'll talk about the Drake equation, which I'm sure you've seen if you're interested in this subject elsewhere. I have a few slightly unique things to say about it anyway, so I might as well go ahead and do it. I'm going to write it down on a big bit of paper so you can see it. So I won't be sitting here looking at the camera all the time, I'll just be talking and you'll be looking at a bit of paper. It's not going to be visually terribly interesting, I don't think, unless I can work up some special effects at some point, who knows. But the basic idea is there are probably about 100,000 million stars in our galaxy, and there are around 100,000 million galaxies in the visible universe, and the visible universe is actually only a small portion, we think, of whatever else is out there. The point is, that's an awful lot of stars, and it seems, on the face of it, pretty unlikely that we are the only creatures in the entire universe, or even in our galaxy with 100 million stars, that is 100,000 million stars, 100 billion in the American format. That's an enormous number. And if life, and intelligent life, is at all easy to generate, even slightly easy to generate, there ought to be quite a lot of civilizations out there. And the Drake equation is, it can't prove how many there are, because there are too many unknowns, but it can give you some idea of what we need to find out in order to make a sensible guesstimate. It's a subject for discussion, really, rather than proof. Normally with equations you can find a single solution or a pair of solutions or something like that, but the trouble is with the Drake equation, it consists almost entirely, well, pretty much entirely of unknowns, and therefore there's as many solutions as you like, really. There must be at least one civilization in the galaxy, because we're here, and at the other extreme, every possible star in the galaxy could have a civilization, and that would be 100,000 million civs. I don't think that's very likely. But how likely is it that we are the only one? Don't know, but we can discuss it, and let's look at the equation and get started with it. Right, so here we are, and let's start off. We'll write out the first part of the equation. What we're trying to do is find the value of n, which is basically the number of civilizations that we can communicate with in our galaxy. Not in the entire universe, but just in our galaxy of 100,000 million stars. And that's known as n. And what Drake figured out, or guessed if you like, was it's dependent on a number of factors. The first one is known as R star, which is the rate of star formation in the galaxy. Originally he chose a number of 1, but that was raised to 10. Nowadays we think on average the number is about 7 stars being formed per year in the galaxy. Of these, what it's multiplied by, that number is multiplied by the fraction that have planets. Now, in the early day they thought maybe 1 in 5 stars had planets, but after the Kepler telescope has been looking around, we now know that nearly all of them have planets. So at a minimum it's going to be about a half. The fraction is 0.5. Say, have some sorts of planets. The problem though is what fraction have planets that are capable of developing life as we know it? The fraction of Earth-like planets. Now, it's hard to guess. Most of the stars, at least half, have planets. How many of those have Earth-like? It is a guess, but when we look at our own solar system, Earth-like can be taken as a rather general term, because there are a number of planets or bodies in our solar system that could be life-bearing. There's the Earth, we know, Mars, there's Jupiter's moon Europa, and indeed Ganymede, which also appears to have an undersurface ocean, and there's Titan around Saturn, there's Enceladus around Saturn. So there's actually quite a decent percentage that could be having life on them. So around these stars that do have planets, the fraction that might have life is probably greater than 1. So we can be conservative and say 2. Drake actually chose 2 as well, because he was thinking of Earth and Mars. We don't know whether any of these other worlds in our solar system have life, of course, but if life is fairly easy to generate, and we'll know once we've discovered whether there is any there or not, then the fraction is going to be high. If not, well, we just don't know. We would probably have to say 1 there, because the one solar system we know has 1 planet with life on it. Let's put a little equal sign there. Now, how many of those planets actually will develop life? What percentage? Well, all we can bet is that life is probably easy to generate because it has appeared here, and it appeared as soon as the Earth was cool enough for life to actually survive on it. So it's as if life is extremely easy to generate. So I think Drake chose a value of 100%, or 1. I think that's not a bad guess as well. Life may be very common. You might want to put a smaller figure there. Maybe when we've explored these other planets, we'll have a figure for the odds, I suppose. Although the planets in our solar system may, of course, be contaminating each other, there is a theory that life actually began on Mars first, and when Mars was struck by an asteroid, rocks were splashed into space, because it has quite low gravity compared with the Earth, and some of them landed here and contaminated the Earth, and we're all Martians, basically. Either way, if life is hard to generate, then that number will be very different. If it's easy, it could be higher than that even. 1 is a compromise, it doesn't change the value of the rest of the equation. Now, how many of these life-bearing planets will develop intelligent life? Now again, if we look at the planet that we know, Earth, intelligent species include humans, dolphins. You might say, what? Are they intelligent? Well, actually, yes. You have to wave your hands a bit about what intelligence means, but they are about as smart as humans were, say, 100,000 years ago. So that's pretty smart. There are other fairly intelligent species: dogs, cats, elephants, obviously the great apes. Birds seem to be very intelligent, certain ones, especially the crow family. Crows, jays, jackdaws, that sort of species. Parrots. They can apparently learn a vocabulary of quite a few words, and they can even do some basic maths, arithmetic. And they come up with creative solutions to complex problems. And that also means that probably there were intelligent dinosaurs, especially if Steven Spielberg is to be believed, eh? The velociraptors and others may have been quite smart. They had bird brains, and bird brains are very efficient, more efficient than mammal brains. So, on our planet there are several intelligent species who could, if humans were to vanish, some of those could develop into tool-making, civilization-building creatures. The great apes, maybe, if they don't die off. They're not far off, after all, being wiped out by environmental change caused by us. Dolphins and other undersea creatures would have a problem, because under the water you can't really discover fire or do much with it, and you can't smelt metal. It's a bit of a bad environment. They could be great philosophers, but they probably can't build an industrial civilization. Elephants, maybe, if their trunks, because they can use the tips of their trunks to grab things, and they've got opposable noses. So maybe they could do something, but they're not very dexterous. They would have to evolve considerably to become better than that. But still, the fraction of life-bearing planets that bear intelligent life, it actually looks like it's quite a high proportion, given that there are so many on our planet. So again, I'm going to say it's about 100%. 1 out of 1. All of the ones which can do, given long enough. I mean, it's taken, what, 4 billion years for us to appear? 3.5, say, for most of the dinosaurs. It's a long time, but eventually you'll get a result by the looks of it. How many of those, though, become communicating civilizations? Ones that, not just ones that deliberately communicate, but ones that we can detect. That is, they maybe pollute their atmosphere, or they become super advanced and engineer their stars, or clean up all the rubble around their solar system and use it, or something. Or they actually deliberately, like some people say we should, send radio waves out into space. We are inadvertently sending electromagnetic pollution into space. The electromagnetic pollution is radio waves and TV and so on. It's not necessarily safe to do that. We don't know what's out there looking for us. There could be predators. And we'll talk about that maybe in a while. So it might be that civilizations communicate for only a short time. We'll talk about that. But of those that develop intelligence, how many communicate? Well, I've named half a dozen intelligent species, of which only ours communicates. So the fraction of those that communicates, maybe, I think, they put a fraction of 0.1 to 0.2. I'm inclined to be the same way. Even with our human civilizations, there's no necessary reason why we would beam radio waves into space. For certain, we might have gone straight to cable or something, who knows, but it's probably something like 0.1, say, 1 in 10, say, communicate. And the final factor is how long does such a civilization last? How do you estimate that? Now, common estimates are between 1,000 and 100 million years. I think Drake himself chose 10,000 years. I personally think those are hopelessly optimistic, for a couple of reasons. First of all, when we look at human history, we've had nuclear weapons for, well, 60 years or so. In that time, there have been 2 occasions when nuclear war nearly happened, and in both cases it was averted more by, or as much by luck as by judgment. There was the Suez Missile Crisis, not Suez, the Cuban Missile Crisis, when the Russians did actually apparently give some orders that weapons were to be fired, but one of their soldiers in charge disobeyed, and it didn't happen. And I guess they thought better of it, I don't know. And the other one was, I think, in around 1985, when there was a bit of a crisis and a Russian submarine was underwater, and the Americans, not so cleverly perhaps, dropped depth charges on it to communicate with it, to tell it that the crisis was over and they could surface, but of course the Russians down there didn't know. They thought they were being attacked. And they had a rule that 3 of the commanders had to agree before they could launch weapons. 2 of them wanted to, 1 didn't want to, so it didn't happen. But you see, in 60 years we have come close to annihilating ourselves twice. So I think the length of time a civilization will last, since we've got through it really by luck, is short. I'm going to say 100 years. That's okay. On that basis, we're going to have another crisis or so at some point soon. So 100 years. They either exterminate themselves, or they get attacked by some aliens, or that might happen. That might take a lot longer than that, because distances in space are huge. Or they have bio-warfare, or they invent the artificial intelligence which destroys them, or something. But this gives you a total of the number of communicating detectable intelligences in the galaxy that we could possibly match. So let's try and calculate the answer, shall we? 7 times 0.5 times 2 times 1 times 1 times 0.1 times 100, that equals 70, by my estimate. 70 communicable state civilizations in our galaxy. I've crossed that 0, but I haven't crossed the others. Let me be consistent, eh? How about that? In our galaxy. Most estimates are bigger than that. One thing you will note, and this is what happens with most estimates of n, is the number is approximately equal, very roughly equal, to the length of time the civilization will survive. So all these other numbers more or less cancel out, good and bad, and it's the crucial factor seems to be how long the civilization survives. But of course you could have very low values for some of these. Maybe Earth-like planets are in fact extremely rare. Planets we know are pretty common, but Earth-like planets could be very, very rare indeed. And it may be that although life might form easily, complex life might be extremely difficult to get, like multi-cell organisms or something like that. It did take billions of years on Earth after all, so maybe that's extremely difficult. I think once it does get complex, the odds are intelligent life isn't that difficult, because there is so much of it on our Earth. And it's formed in more than one way, with bird brains and mammal brains, and even the octopus is pretty smart, and that's different again. So these 3 are probably going to be largest numbers no matter what. Or, sorry, those 2 intelligent, but this one is probably, these 2 are likely to be low if they're not like this. It remains to be seen. But if there's if there are 70 civilizations in our galaxy that we can detect now, it's probably been like that for 1 billion years. They might live for 100 years each, or stop communicating after 100 years, but then another one will pop up, because there's 7 stars a year forming. It sort of builds up. Why aren't they here? This is known as the Fermi Paradox. I mean, supposing a civilization developed 100 million years ago, the first one, they would have had plenty of time to colonise the galaxy. Even at sublight speeds, they could have spread to hundreds of thousands of stars and suitable planets. And yet, when we look out there, there's gas, there's rubble, there's no sign of them. And the CT project, a program which is looking for civilizations, has heard not a peep that can be definitely explained as being civilization. Now, they would argue that they've actually only examined a few thousand stars properly, so they've hardly searched any of the 100,000 million that's out there in our galaxy. And of course we could look at other galaxies too, on a large scale, and see if we can see something. But you would think, given that the Earth has been suitable for a long time, and other planets presumably have not all just been working on the same timescale as Earth, and they haven't all just started building civilizations right now like we have, there should be super advanced civilizations out there, unless there are problems with that. The problem would be great filters. I've mentioned some great filters. Are there enough Earth-like planets out there? How many of those develop complex life, or life at all? But certainly complex life is needed to get to intelligence. It may be extremely difficult, and very few. There also might be extremely few Earth-like planets, as it turns out. It might be that the combination of factors you need, there's quite a lot of factors you need. The right distance from the star, a stable star, the right components in the atmosphere, luck, who knows, all sorts of things. And for complex multicellular life, that might be a rare process. We don't know enough about it. But there are other great filters which operate, we've got here, but there may be other great filters which operate in the future. There may be filters also that prevent intelligent life becoming as intelligent as us, and we just happen to do it by luck. But clearly, nuclear warfare is going to be a great filter of the future. There's a good chance of us nuking ourselves. There's a good chance of us going for bio-warfare or some other great destruction, or simply environmental degradation could cause our civilization to collapse, or our economic system, which wastes resources grossly, could use up some crucial ones that we need to get to the next stage, or even ones we need now, and population could have to crash. And indeed, evil psychopathic people might want to do that deliberately anyway, rather than maybe engineering a gentle population decline, which is probably what the planet needs. It can be done through good standard of living and education, or it can be done through war and violence. One way or another, probably the Earth population will decline, and if it doesn't, we will damage the environment probably irreversibly before we get to a technological level where we can live in harmony with it, or a psychological level even. And there are other possible great filters. It may be that our radio waves will be eventually detected by predators. There may be a super smart civilization out there already which doesn't want any competition, and it comes along and stomps on any that turns up. It could be that there are other civilizations out there and they've learnt to stay quiet. Some of them may have survived attacks, who knows. or they may just go for cable TV instead of broadcast TV and whatnot. Other great filters are, of course, asteroids striking the planets. We know that our own solar system is kind of unstable. The orbits might change. There are lots of possible ways of exterminating civilizations. So, and there will be things that we haven't thought of yet. The information age may throw up all sorts of possibilities. Bad government among them. Well, I hope that's given you some idea of whether there's life out there in the galaxy. I mean, that's a low estimate. Most people go for much bigger estimates than that. Some people say there's far fewer. If you get some of these numbers low enough, you can see that we would be the only ones in the known universe. There's also another factor you might add on to this, actually. I don't know what it's called officially, but I will call it the frequency of recovery. Supposing a civilization crashes, what are the odds of it redeveloping again? Or one of the other intelligent species on the planet becoming intelligent? That's probably something like 0.1 again, isn't it? So, but I don't think that's a multiplying factor. I think that that would actually multiply your numbers. If the chance is about 1 in 10, I suppose it would multiply this figure by 10, and you get 700. So that, I guess you have to divide by that one to get a plain sensible answer. Am I doing the maths right? I don't know, but you can see that one planet could host more than one civilization at different periods in its history, and that would increase the number. If I divide by 0.1, that multiplies it by 10, so in that case there might be 700 at the moment in our civilization. In our galaxy, sorry. And of course, of these civilized communicating civilizations, remember that we can detect them not only if they're communicating, but we can detect them in other ways, like pollution and so on. The fact of oxygen in an atmosphere will tell us that there's life there, probably, because on our world oxygen is a pollutant. The early life didn't have an oxygen atmosphere, it was methane and things like that, and they turned it into an oxygen atmosphere. Well, I'll stop there. Put your own numbers in and see what you think. Okay, bye for now. One last note, I've thought a bit more about that last factor, the recovery factor, and the way I've done it, dividing by 0.1, is probably overestimating, and probably the best way to do it would be multiplying by the number of civilizations a planet might host. Say on average, given that the lifespan is short, 100 years in my estimate, maybe a civilization can recover twice or 3 times, or a new species can evolve over 100 million years or something. So better to multiply by the number of civs a planet might host over its entire lifespan. 2 might be a good guess, who knows. Other than that, I think, and it still gives you roughly the same estimate anyway. Instead of 700 it would give you 140 if I set the values to 2. Other than that, I think this is basically how we work it out, but of course it's all fudged and unknown. We know star formation, I can't even say it, formation rates, we know planets. We can have a guess at how often planets are in the habitable zone, but from life onwards we know very little, because we have only one example, and doing statistics on a sample of 1 is bad maths. So anyway, that's all I have to say on it at the moment. If you have any comments, please leave them below, and we'll see how it goes. Okay, bye.